All right, it has been recorded. Welcome everyone to our second implementation week for the DDPG. Has any of you gotten a chance to work a little bit further on the implementation side?
No,
Okay.
I have
uh,
not had a chance to look at DDPG implementations this week.
okay, that's fine. I'll present my findings, and if any of you would be interested in jump in, feel free to do so. So this week, what I did was I experimented with two things. The first thing is I experimented with the effective noise. So as we discussed in a paper, the original paper used the Ornstein-Uhlenbeck action noise, and the OpenAI spinning up repo, they use the simple Gaussian noise. So I did a comparison of them. And if you go to the OpenAI baselines library, they actually, oh, looks like it just crashed. The OpenAI baseline library actually has a very nice file containing all of the noise implementation.
I think you're not sharing your screen right now. So.
Oh, right, my bad. Sorry, hold on 1 second. All right, can you guys see my screen?
Not yet. Yes.
All right,
Yes, we.
perfect. So as we were mentioned last week, the original paper implemented the Ornstein-Uhlenbeck action noise, but the PPO, the OpenAI spinning up repo, they implemented with the normal Gaussian noise. So this week, that's the first thing that I investigated into, which is which noise would produce better results. And if you go to OpenAI's baselines library, they actually have a nice file, this DDPG noise file that has all of the action noise that they implemented. So, for example, they have the adaptive parameter noise specs. So that's a different paper that they claim to get better results. But I do see some people are struggling with reproducing their results, which is quite common in the reinforcement learning world. Right. So the other thing that I experimented was the batch normalization, which seems to be the case that all you have to do is to plug in the PPO tricks, the normalized environment that we had in the PPO2 continuous action, and then plug it in, and then it seems to be working quite well. But the experiments takes a long time to train, since as again this is a replay buffer types of algorithms. So in my experience, they take significantly longer to run. But let's another thing that I want to point out, which is kind of interesting. I also posted in the Slack channel, is that DDPG seems to the OpenAI implementation of DDPG seems to do the normalization twice on the returns, and it's kind of a weird thing. So if you see their run um, and their file, their run.py, which is the file that bootstraps all of the experiments, that includes the normalized environment already, which is this line. If the environment type is Mujuko, then you normalize the observation, normalize the returns. However, if you go into the DDPG's um, actual model, what you're going to find is that they also do another pass of normalization, which is probably here. No, it's not here. Maybe it's DDPG learner. Right. So you see here, they do the observation normalization as well as another round of return normalization after the environment has already been normalized by using the vector normalization. So if we open that, which it doesn't let me automatically. But if you go vecenv and vec normalize, what you realize that is that they're already using the observation and return normalization. So I don't really get why they would do it twice. It almost seems like a bug in the repo that has not been addressed, and it has someone already posted an issue on it. So it's not like no one mentioned it before. So, but anyway, so that's the thing that I was investigating. Any questions so far?
So how are the results?
Yeah. So here are the results. Which, as always, takes a long time to load. So this is a pendulum, and then if you reach like 100 or so, that's very good. And then here we have DDPG noise. DDPG2 noise is the one with the environment normalization. So that includes observation normalization as well as return normalization, reward clipping, all that kind of all that kind of stuff. So I'm training on a big server, our big server, and for whatever reason, the training is very slow. This has run for 6 hours, and it only has gone to 80k time steps by using the CPU. I really don't know why, but that just seems to be the case. In comparison, just running the experiments on my machine, which also uses CPU. I use the AMD CPU, and it's much faster. It finishes within 11 hours. So on our big server that uses Intel CPU, it has run for 6 hours and it has completed maybe I don't know, 1/10 of its trajectory. And overall, I would say the impression is that their performance is pretty good. However, they suffer from um, keep coming back. So their performance just kind of stabilize in a suboptimal setting. It doesn't learn as well as some of these curves that are really smooth and nice. So, by the way, this is PPO2 sanity check, as they claim it, but this is more like DDPG's result, which is kind of just shaking around. It's more like this. It definitely learns. It just it sort of unlearns a bunch of things, and it's kind of frustrating to debugging and figure out why. So I'm having high hopes for the normalized environment. So far, it has been on the higher side of the performance, but we'll have to wait until the experiment finish. So this experiment, which I believe is a Hopper env, and as you can see, the performance seems to be more stable with the normalization on the environment and returns. But there's not enough data to see clearly. I guess you can kind of see over here a little bit that they seem to perform a little bit qualitatively better, but we don't know whether it's gonna drop like this does, you know? So yeah,
Exactly.
that's about my findings this week.
So you said observation and reward normalization. Is
Yes.
that it?
Mm-hmm.
Okay.
Yeah, I don't know how you guys think. Oh, hello, Nicola. How are you? Anyway, do you guys have any questions or comments? Right. The other thing that I would say would be interested Um, right. The other thing that I've been considering is that maybe we shouldn't spend too much time on debugging with many issues with the DDPG because it seems to be just unreliable, sort of unstable algorithm compared to a lot of other algorithms. Oh, by the way, this seems to be showing that the reward normalization is performing really well. It's already the observation and return normalization. It has already exceeded the best performance of the agents without the observation and return normalization. And the other thing is the noise doesn't seem to be matter that much.
What was the environment?
Huh. So this is Hopper.
Hopper, and how the rewards looks like for the Hopper?
I think for the Hopper, I'm not exactly sure actually.
Because I think this is actually very important, right? To That's what differentiate different environments, and this is very important for the reward normalization. That sometimes reward normalization might work for this environment because of the how the rewards are.
Right,
I
right.
think.
So that's something I agree. That's something that we can definitely take a look. So, for example, right here, if I just run it, and then it's gonna start up and prints out something, and then we can print out rewards. So for one thing, we know its rewards is not something like one. It's not like a one just give you a reward of one for every time step this game goes on, but rather it's more based on some sort of heuristics. So
That's why, for example, I don't like Pendulum, the environment, because it always gives you like reward one, right?
uh huh.
And I think, yeah, it's kind of very different from other kinds of like environments. So uh, uh, it's very difficult to switch between from the pendulum to other kinds of environments because of the nature that normally in the different kinds of environments you will have reward for achieving some goals, whereas here you always getting this one one one. uh,
Mm-hmm. Yeah, so I would say something similar. You can look it up on their. So this is the Mujuko's implementation of the Hopper, but I would imagine them to be very similar. And the way they define reward seems to be there's like a live bonus, but there's also some sort of positioning bonus with a Hopper. I guess it doesn't want you to move in a terrible position. I would imagine if you move to a different position, it'll probably
I
give.
would say it just rewards it proportionally to the distance it has traveled.
Right, right. So as you can see, it's trying to move forward. So I would imagine the more you move forward, the larger the reward you're going to get. And if you fell, you die, right? Something like that. So I think a very naive approach to solve this problem would be just to stay still. You don't do anything, and then you always get the alive bonus without actually exploring the space.
That is true.
Yeah.
But given that there is some exploration due to the noise that is passed on the action, the agent is bound to understand that when moving to the right, there's gonna be a higher reward. So,
Yes, the theory should be that case, right?
okay, the theory maybe.
Yeah, and let's take a look at this without a normalization of the environments, which again seems to be stuck. Well, this is a fun time.
I think it would be nice to compare, for example, to lunar lander, right? When you are, I think, rewarded for landing, right? So uh, you got very sparse reward.
Mhm.
right?
Right,
If you
right.
know.
Sparse rewards is always a hard problem to solve, just in general. Uh, yeah, let's take a look at this one without the normalization. Well, I guess we can. So it is performing in an interesting direction, I suppose. But yeah, in general, the performance is not like it's not like a smooth curve. So that's the thing that bothers me the most. And I almost wonder how much is worth it to sort of trying to debug with the DDPG, because it seems there are the TD3 seems to be addressing a lot of the concerns of the DDPG problems. So if we read into the TD3 paper and just kind of ending the DDPG implementations without too much optimizations over its code, we might gain better insights when we do the TD3 paper, and maybe we can come back to DDPG and optimize it. Because right now, it just seems that we're we tried a lot of techniques with the DDPG, but it doesn't seem to be qualitatively improving its performance. So
What is the reference? I mean,
Exactly. Yeah.
what is the expected?
Yeah.
Are you
Relative to what?
at the SAC-like result, SAC-like result with DDPG, but
if you see the reference, it seems to be pretty good with the DDPG. Let me see if I can find it.
do they say how much they smooth the curves?
With DDPG, or
DDPG,
I
yes.
don't think that's something that's commonly specified in papers, but they do have much smoother curves. If you look it up, like their performance is much smoother, right?
Obviously. But they do not also test the pipe bullet itself. It's a joke,
Actually,
right?
sorry, that's not the correct one. Oh,
And
you
the
know what? They don't show the training curve. This is for the original DPG. This is not the DDPG. They don't show the
okay.
training curve. They just kind of show the average result, which is, if you think about it, if their performance graph is sort of embarrassing, like we see here, that it's constantly unlearning and learning again, maybe that's the reason why they report it in the form of average. Because if you look at the average, it's still pretty good, but
But
Okay.
it's kind of like interesting, right? Because uh, I would think about this algorithm as a kind of like extension to Q-learning,
yes,
right?
yes. Hmm.
So it's kind of like unintuitive why it behaves like this. It's strange.
Yeah,
Uh,
so for example, if you see this environment, its best reward is much better than the average reward, right? This is like a 5 times difference, right?
yes, but it's very meaningless statistics, right? To have like uh, best reward, right?
Yeah, I suppose. Well, I was just trying to get a sense of how far away. So it could very well be the case that, so for example, here would be the best reward, right? Something like around. Actually, sorry, this is already smooth. Um, so if we get into any of those, like their best performance might be really good, but like over here, it's about 2,000, right? But its average is probably 500. So that corresponds to some of the findings in the paper, right? That the best reward is about 5 times higher than the average reward. Where's the paper? I just lost the paper. Okay. Oh, never mind. Yeah, but yeah, that's just a possibility. They don't really show the training graph, right? So we don't know. And if you read this post, which just kind of talks about a bunch of problems that they've been having, it seems that this is a more common issue with DDPG's reproduction. You, it's rare that you see smooth curves. You still see some, but it's not as nice as the one that are being posted in the paper. In
So,
comparison,
yeah. So my question would be, what do you think it might be the reason?
I have no idea. This is one of the things with deep learning, with the reinforcement learning, is that in cases like this, it's very difficult to figure out what's the problem. I guess this is especially hard when it learns than it unlearns. But in comparison, PPO is like performing so much better, so smooth compared to whatever these are doing. Like half cheddar 02. This is degenerate. This is goes to negative 500. And in comparison, like
And
this
when you're talking about the PPO, you're talking about the pure PPO or the actor critic version?
PPO is an actor critic version,
Okay, so this
right?
in actor critic sense. So there is a like critic and the actor. Okay.
Right.
No, I thought that PPO can be used as a only policy gradient. Without the
Um,
actor, without
A2.
critic.
Oh, okay. Right. Well, PPO is sort of the actor critic kind of algorithm.
Okay.
Yeah. I think there are only two main strand of algorithms. One is the sort of the temporal difference learning, and the other one is policy gradient. So PPO, A2C, SAC. SAC is sort of like in the middle. It's kind of weird. But yeah, those belong to policy gradient, and the DQN, DDPG seems to be more on the TD learning side.
Yeah, and TD3.
Hmm. But yeah, do you guys have any other questions on DDPG? Um, right, because I was thinking to move forward. Maybe what I'll do is to basically take the version with normalized environments, and I can run two sort of benchmarks. I can run it with with or without the normalization of the normalized env. But I think for investigation purposes, we should just run the DDPG without the normalized envs, and just put it in the big benchmark, and see how they compare, how their performance vary compared to the other methods. And then I think we should just move forward to TD3, and maybe come back to DDPG if we have more insights on why it's performing so um, erratically.
Sounds good to me.
Yeah, because initially why we implemented DDPG was because DDPG was a proxy to TD3, which is one of the best performing algorithms in the continuous action domains. If you go see um, benchmarking model-based RL. Someone wrote a paper about it. I'm sure implementation matters, and their results might not reflect what will actually happen with our results. But if you see some of the findings, like for example, right here, what you'll find is that SAC and TD3 are always the best performing one. So SAC is the red one and TD3 is the blue one. In almost all of the experiments, either both SAC and TD3 seem to exhibit very stable performance. And we can take a look at DDPG as well if they no, they did not include it in their benchmark. But Yeah, for example, like this would be a Walker 2D. This would be like a very clear example. The DDPG, the TD3 version and SAC version is performing very stably. But yeah, I think that's something that we should probably try to push for. All right. So if no one has any more questions on DDPG, maybe we should start presenting on the sort of various cloud integration that we're trying to have. Why don't I go first since I'm already presenting? So I did a yeah, Ali. Are you ready to present?
I can go after you. Yeah, go for it. I had to step off for a quick call, but I'm back. So after you, I'll just go ahead.
All right, sounds good. Sounds good. So a couple things that I did. So the first thing was AWS Batch. So that will be very similar to what Ali was is going to present. Um, so AWS Batch is a managed runtime. So if I go to my AWS setup, and I go to batch, I can also show you the billing. So AWS Batch is a managed runtime. You just submit jobs that are defined in a Docker container, and it'll just run it for you. So what you need to do is define a computing environments. So you need to specify the maximum number of CPUs, the minimum, and the desired number of CPUs. And it'll the more CPUs defined in your job is specified, the more instances that the AWS is going to spin up for you. And you can also select provision model. You can select low priority machines in the Azure's term, or in AWS it's called spot instances, which are up to 70% cheaper than on-demand instances. So that part is sort of handled for you, and you just create a job queue and then you submit jobs. And the process looks something like this, where I build a Docker container first. So something look like this. And then I call the AWS batch by submitting jobs. And then, right, so let me show you this. So an example, oh, go ahead.
That's a good question. Are you able to create those resources from the SDK as well, or do you have to create that from the AWS website?
Create what? Sorry.
Like the actual, so like to create the batch pool with the spot VMs
Yes,
and so
you.
on.
So if you use, so I do have a setup script that set up a job
Okay,
queue and a job definition.
perfect.
But I think I'm pretty sure you can set up the computing environment as well, all by scripts. But um, yeah, I think you can do it both ways. You can do it either purely by using a client, or you can use a GUI to do it.
I see.
Or you
Um,
could use Terraform. It's another way.
Sorry, what?
Terraform. So basically, this is a tool that you can, spin up environments, AWS or Google Cloud.
Mm-hmm.
It's kind of like generic purpose language, for.
Right, right. Yeah, but I think with Terraform, you need more things to sort of manage it, right? It spin up the instance for you, but how do you manage them and terminate them seems a lot of extra work, I guess.
It's probably, yeah.
But anyway, let me show you the cost. So I ran about 80 or 40 experiments, and this is how much it cost. Bill detail. And I would say it's quite expensive. more at least more expensive than I imagined. So it takes about $5 to run 40 hours of experiments, 50 hours of experiments.
How many machines? This is for six.
Yeah, so
Oh no, how many machines are you running at any given time?
I think since I set the desired number of CPUs to be 10, I think at some point I saw four X large machines being spin up. And notice this, these are already spot instances, so they're already 60% cheaper. So it is quite shocking to me that I was expecting more like $1 or like 50 cents. But I guess this is kind of how it goes. But yeah, so that's for that. And the other solution, since this is too expensive and they don't allow you to include your own computational powers to be included in the pool that executed jobs in the AWS batch, I was I was looking for other options. And one option that looks pretty promising is the Nomad. So, have you guys heard of Kubernetes?
Yep.
Yeah,
Yes.
yeah. So Kubernetes. Oh, I don't want this. Kubernetes is like a platform that schedules Docker jobs, but it's very expensive. It's very heavy. The runtime itself, at some point I remember, it just takes a lot of CPUs and memories by itself. So I was looking at a couple solutions. One is K3s, which is a lighter version of Kubernetes. The other solution I was looking at is Nomad. I eventually choose Nomad because it has a job queue, but Kubernetes doesn't. The job queue you need to sort of handle it yourself, but in Nomad it is handled. So uh, all you need to do is something like this: you set up a job profile, and then you set up a Docker container. You tell the script how many CPU you're going to release it to it, and then the run file looks something like this, where you connect to your server and then you just run. Of course, you can set up a secret, which is what I did. It'll read environmental variables and then you can connect to it. So right now I connected the our lab server as well as as well as the machine that I'm currently using. So ideally, it's going to allocate resources, allocate jobs based on need, I suppose. And I do have something to say about that, which is initially I thought all I had to do was to let the container does its things, but apparently you still should use you still should use environmental variables uh, such as the MKL num threads and OMP num threads for PyTorch to make it not use too much CPU. Because if you don't do that, then the Nomad runtime will have to manually throttle the CPU to PyTorch, which I think is something that makes it run very slowly. Um, and it also doesn't put jobs in a queue until your CPU is very strained. Like there are some ways to tune it, but I find that to be a little bit disturbing and probably need more investigation. So I posted an issue actually in their GitHub repository, and I can kind of show you how many experiments I was running. So where is going to be my thing? So as you can see at the time, my CPU was going for 400%, and memory is also kind of blowing up, and but it still wasn't scheduling new jobs in the queue. But eventually, it did once I run another 80 experiments, and then it says 34 pending. So those are in the queue. So overall, I think it has a lot of potentials, especially if you want to include your own computational power as part of the batch job execution process instead of solely relying on the cloud. Um, but yeah, and also Nomad, I'm pretty sure it's going to be more complicated, but they also have repository plugins that allows you to auto scale it on demand. If you need extra computational resources, it'll spin up instances on AWS or GCP or something like that. But yeah, any questions on this? Cool. So, Ali, would you like to take over and do a little magic on the Azure Batch?
Not sure about magic, but let me try. So that's this screen.
It's gonna be my first time with Azure.
Okay, that's fine.
It's gonna be exciting.
So can you see my screen okay?
Yes.
Okay,
But
so
my sorry, hold on one second. My thing is bugging out. Yeah, I think I got it.
Okay, so this is two set of scripts. One is called Batch Creation, and one is called Batch Containers. Put this over here. This one creates all the resources that you need, run batch jobs on Azure Batch. It turns out that Azure has a CLI that's actually written entirely in Python. It's kind of weird to with the CLI, not in Node.js or something, but in Python.
Right.
So just use a wrapper for that CLI to make all these functions to call on Azure to create, for example, your batch account, create a registry where you can host all your Docker containers, and then create a storage account so that you can save some data after you run your batch job to persist the data somewhere. It could be logs or so on. And all of these services create a access key, like a password that you need to interact with the resource. But you can also get those by extracting it from the CLI. So what I did was I created another class that just pulls all of those values out. All right, so this will, for the first one, creates all your resources. The second one gets all the passwords and keys. In order to make it easy to use it again, I have this function that writes all of that to a config file. Let me peek what that looks like. I'll show you the skeleton version. So basically, it creates this config file that looks kind of like a YAML file that has all the values you need, such as the pool name, the storage account, and so on. The most important part is this is all written to use Docker containers. So you have to build a Docker image that you push to ACR. So what this does is it takes a Dockerfile path and it builds that image on ACR. ACR is the Azure Container Registry.
Yeah, and the same name like AWS.
Yeah, it must be very similar. I think they're all in competition, so they try to make things easy to transition across each other. Yeah, so that's all this script does. And it's very easy to invoke. All of these, in this case, really the only thing I do is I call the create resources function, which will first create all the resources, and then it will write all the resource credentials to a config file. This one builds the image and pushes it to ACR. The nice thing about this is that you don't need Docker locally to build the image because it actually builds it on Azure.
Oh, really? Okay.
Yeah. Okay, that's all that. I'll show this one, which is more interesting. This has a lot of functions because it's not easy to predict what the user wants to do beforehand. So what it mainly does is it creates a batch account. So in the previous one, we create kind of a pointer to a batch account, and we create the virtual batch account. Don't create any virtual machines there or any VMs that have containers yet. So that's what that function does. It says, okay, in the config file, you tell me how many tasks you want to run per container, how many dedicated nodes you want, how many low priority nodes you want, spot VMs you want. And then here we create the actual pool. So you can see here it says, I'm going to create a pool with this name. It has some configuration, which basically means it has some type of underlying virtual machine type and some container image to use. And then it will create it from that configuration with some dedicated number of nodes and low priority nodes. And then some function to delete the pool and delete the job.
Okay.
The pool is the underlying hardware environment. It has underneath that a notion of a job, which is a collection of tasks. The simplest way to see that is here. Here is an example task. I'm saying for these number of tasks, run this script. In this case, this script is a pretty simple script that has 4 parameters. It says I want to run this job this many times on this port with these other 2 parameters, which are project specific.
I have a quick question.
Yeah.
So did you write a majority of these scripts, or are you just sort of introducing on the Azure Batch official repository?
No, I wrote these scripts, but they do use ducks that I learned from the Azure Batch.
I see.
Example.
Okay.
I think there's something called Azure Batch Examples here. Let's see this. It's just my history. Take the Hello World example. You can see here is probably very similar. Submit job and task. I think it's coming from these samples, but just rewritten to be general. And I've used this for many different projects. That's why
I see.
For
right. So my primary concern. Yeah.
Go ahead.
My primary concern would be how easy would it be to get into just to submit a job to set everything from scratch, and the other thing is the cost, and it seems.
So I show you an example of how you invoke these functions to create what you need. From my experience, the most difficult part is just create a Docker image.
Really? Okay.
Yeah, like once you create the Docker file and you make sure everything you have is contained in there, it's all the dependencies are taken care of. After that, running a job, stopping job, restarting jobs is actually pretty simple.
I see.
So basically, all you do is run this function. So let me actually show it to you. I try this right now, make sure it works. As I'm running the bash containers script. It actually has some. I wrote it so that it can take hits. I'm not sure how else these inputs are, but let me show you the help for it first. Basically, this has it has some required arguments. Let's see. I'm not sure why I'm not showing correctly. Yeah, so there's no arguments here you need to worry about. Did you run it? So run tasks and then do help. If this one takes these arguments, number of tasks you want to run, don't worry about this. This is for my specific project. Number of low priority nodes, number of dedicated nodes, the pool name, job name. Note that all of these things, low priority node, dedicated nodes, pool name, job name, I allow you to add your own argument, but by default, it'll just use what's in that config file. So you can change that yourself in the config file, or you can provide the parameters here.
I see.
And I ran it. For example, I ran 128 tasks on 64 VMs, 2 dedicated nodes. And I said, make a new pool name call this, and it's running the command on every container in that pool.
Right.
And the actual creation of the images was similarly simple. It was batch creation. build image and create resources. Build images, you can just ask for where's the directory of your paths.
Uh-huh.
So in my case, everything is here, so I just move this path. The Docker file here. It already does everything you do for this project.
Right. Oh, by the way, I thought Mujuko wouldn't be able to run in a Docker container.
No, it's actually a Majoko Docker file.
Really interesting.
The Majoko Pi instance is a Docker file. The repo itself is a Docker file. I just rewrote it a little bit because they always use this specific base image, which already has CUDA, but
can you still run it? Do you need to download like a license for it?
Yeah, of course. So you need your own Majoko license.
Okay, I see.
And this assumes that it's in your local directory from where you run the build command.
I see. Okay.
So yeah, in my case, I'm just using the NJ key that I have here.
Right, I see.
I have it up here. Make a copy of it every time. Okay, yeah, so that was how I ran it. I don't use the Azure website because it's not the easiest thing to navigate, but it's this thing called Batch Explorer, which is like a free GUI service to look at your Azure jobs and monitor them for batch jobs, rather.
I see.
So this is me. I just ran that job. I asked for 64 low priority nodes and 2 dedicated nodes. These are Ubuntu 1604 images.
I see.
So this is costing $3 an hour right now. Let me actually try something.
So $3 for the about 200 cores over there.
Yeah. Actually, these are 2 cores, but they're hyper-threaded. So you actually get 4 threads. So that's more like 4 times 66.
$2. So is it $2 an hour per core or?
No, for the entire pool.
Oh wow, that's exceptionally cheap.
I would double check actually how many cores that actually gives you.
Yeah, could you check? Yeah, because that was a major concern as demonstrated by my presentation with the AWS Batch. If I run it for so how much was it? It was like 50 hours or so, and it cost $5. So
no, this is actually only 2 cores.
Okay.
For this machine, but this price is accurate. It's $2.10 for 66 machines, which each machine has 2 cores. So it's like 132 cores for $2 an hour.
Okay, I see.
Yeah, and in my case, I'm actually concerned about that because I'm having 2 scripts, each of which needs its own core. So only 2 cores here, I must be throttling it somehow because I'm actually running this 2 different scripts.
Right.
Yeah, let me try. Let me go back down. I think that's the Tmux actually says something.
So I want to calculate something real quick. So that's 128 cores for an hour. Okay.
That's actually simpler for us.
44 hours.
128 tasks on just one machine.
Well, I don't know. Something doesn't seem right. It seems. Do you have your? Do you have like a billing panel that you can see how much you spend for the month?
I can, but
Yeah,
it's
of
going to
course.
be huge because I work
Right,
in a
right,
team that uses Azure for everything. Let me see if I can.
right, right. And you don't have to show it if you don't feel comfortable with it.
Yeah, it's also being recorded, right? But yes, our bills are really expensive.
Uh,
But I'm not sure if I can only do it for this resource. That might make more sense.
yeah, I'll try to see if I can edit out that part.
Okay, and I appreciate that. But I just ran this other job with just 2 low priority VMs,
Hmm.
and let's just talk about the prices for those 2 low priority VMs.
Oh wow, that's
But
practically $0. Is that just starting?
no, it's still provisioning. So once it gets beside, that will update.
Right, right. So $2 an
Review,
hour times 24 days times 30 days. A month you're still paying a lot. That's like a 1,400 for
yeah,
a,
I don't usually want these jobs 24 hours a day for one. But
right,
yeah, I
right.
think here's the
Mhm.
price for low priority
Uh-huh.
standard ETS in West US.
Right,
The
right.
cheapest actually for one is East US. Let
Hmm.
me change it to East US for that one. And the prices are different based on the machine you use. So
Right.
it's only 2.5 cents per hour. So if you run like even 10 of these for just for the next price per hour for 24 hours, about $6 a day.
Okay. Seems reasonable. Yeah, I don't know. With the cloud
Yeah,
thing, it still seems there's a cost to it, but it's nice to know that we have the options of going for cloud if we wanted to.
yeah. Unfortunately, I haven't set up because I asked for 128 jobs. So
Mhm.
I had this write some math in here. Uh, Basically, it checks how many tasks per node have you asked for. Basically, doing the rounding down the number of tasks per number of nodes,
Mhm.
and then if it's over 75 tasks per node, it picks the biggest VM.
Right,
This
right.
VM costs 40 cents per hour,
Uh huh.
which is why price here is 90 cents.
I see. I
There's no
see.
additional surcharge, I guess. Which region is this in? This is in West US.
Uh huh.
Change the region. Yeah, that makes sense.
Right, right. Even with the sort of a $2 an hour, it yeah. If I now think about it, if you multiply it by 24 hours and 30 days, you're still paying $1,400 per month. Um, yeah, I mean $2 an hour sounds very cheap, but it scales up.
Does add up. I guess you have to ask, how many VMs do you need to run the experiments you want to run,
Right,
and
right.
how long you run for.
Mm-hmm.
I think if we are digital about it, we don't have to run 128 VMs
Mm-hmm.
24 hours a day for
Right, right, right.
all we
Of
do.
course. Yeah,
That's the math.
let's not do that. Yeah, all right. That sounds good. Sounds great. If you could post some information of how to get started with the Azure Batch in the Slack group,
Okay.
it'll be great.
Right now in a private repository,
Mm-hmm.
I can move this to my own repo and then share it with you, or should I just add scripts to a folder in URL?
Either way would work. So what I was planning for is to add the cloud sort of integration in the experiments folder.
Okay.
Just yeah. So I'll push the change and I'll let you know. Don't feel rushed because this is a sort of a low priority support since we already have a big server and it seems currently there's no way for either Azure or Batch to include your own computational power in executing those jobs. I don't see
Yeah.
recently how why would I use it because it's still money.
Exactly.
But it is convenient. Like I remember when I was running at the AWS Batch, it's so easy. All I had to do is to submit, and that's it. And I know it's going to be done. But the problem is,
Yeah, one thing that I'll add is there's always ways of getting free sort of monthly credit for different cloud vendors. I
uh-huh.
know Azure at least gives $150 a month for free
Wait,
if you
what?
sign up for yeah. Let me see if I can get the link for all those free stuff. Uh,
$150 per month free. That's just for a
yeah.
month, right? That's just for a year, right?
Well, so it depends. I think if you do it through a student account, it keeps on going while you're a student. If you do it through an MSDN account, which is available to you if you have any Visual Studio
Wait, really?
subscription, I think.
Wait, student account.
Yeah.
How much free credit do you have?
Let me just double check before I give you the answer to that.
Yeah, if that's the case, I'm saying goodbye to AWS. Huh?
Yeah, I think here it's $100 a month.
$100 a month. Yeah, that's more than enough to run all of my experiments. Hopefully.
Yeah, so I think you shouldn't think of getting rid of one or the other. Just try to use as many free things as you can. If you
Oh
use
yes,
free
yes.
stuff from Azure, free from GCP, free from AWS,
Let-
in Paperspace, you can probably get a lot of free.
yeah, let me see. Free GCP student. Yeah, I'm a student. I'll take whatever you have. Because all I know for GCP is for the first year you sign up, you get $300 free credits, but it doesn't sound like the credits program. Okay,
There
okay.
you go.
Wait, so what do you say? Faculty can receive. Well, yeah, nothing seems to be the same as research credit. Research faculty can. Wow.
This is
Okay.
the fact for the Azure Students one, and I like is that it says if you exhaust your available credits
Uh huh.
or you reach the end of 12 months, you can renew it if you are still a student.
Right. I think this looks great. I'll look it up if AWS has similar things and.
Check if your university has an MSDN subscription. Then you get $150 a month for free as well.
Really.
And I think most universities that have what do you call it? 365, whatever, they get this as well.
Really? Oh my god! All right. No, I'm very hyped. This means I have new ways to run my experiments. That'll worth the time to look into those kind of stuff. Because sometimes when I run experiments using Nomad, it does slow my computer down, especially without properly managed. But yeah, I think I should probably look out for it after our meeting. Probably shouldn't spend more time during our meeting.
Yeah. And I'll see if I find anything either for Azure or for other things.
Mm-hmm.
I'll send it your way. Send it Bruce way.
Yeah. I think that sounds great. Thank you, Ali. All right. Anyone have any last minute questions or comments as our meeting has come to an end?